Given right triangle ABC with right angle C, we can use geometric mean like we've been working on to set up some proportions. Let's take a look at what happens when we set up proportions using the two legs of this right triangle. So the lowercase a, b, and c, as well as the x and the y, are side lengths representing, the lengths of the sides and the pieces of the hypotenuse as they're denoted on the diagram. So if we look at little lowercase a there, a represents the leg of the large right triangle, and the leg, remember, is the geometric mean between the piece of the hypotenuse that it touches and the whole hypotenuse. So a is the geometric mean between x and c. In other words, a squared is going to be equal to, and I'll write it actually as c times x. And if we go over here and we take a look at b, then we've got b is the geometric mean because it is also representing the leg of the large right triangle. But the piece of the hypotenuse that it touches is y, and the whole hypotenuse is still c. So b squared must be equal to c times y. Now, if you remember way back to September, we talked about the addition property of equality. So if we use the addition property of equality, we can add the two left-hand sides of the equations together, a squared plus b squared, and set that equal to the right sides being added together, cx plus cy. Now, if you're good with your Algebra 1 skills, hopefully you recognize we have a c in common between these two terms. So, a squared plus b squared is equal to, factor out your c, and inside parentheses you're left with x plus y. But if you look back up top, x plus y is really the entire length of the hypotenuse, c. So, a squared plus b squared is equal to c times c, or a squared plus b squared is equal to c squared. And you all should recognize this, I would imagine, as the Pythagorean theorem, which means you now have a way to find the length of any side of a right triangle if you're given two sides. You should also start recognizing some Pythagorean triples as we go through this. Okay, so we have two examples here for the Pythagorean theorem. The first is a right triangle that has 3 and 4 to represent its legs, so we fill them in for the a and the b. So we have 3 squared plus 4 squared is equal to x squared, the length of the hypotenuse. And then we have 9 plus 16 is equal to x squared. 25 is equal to x squared, and therefore the length of the hypotenuse must be 5. This is one of our base Pythagorean triples, a 3, 4, 5 right triangle. It's one that's going to come up very frequently, and without even realizing it, you'll quickly memorize it. In the next one, we have a 5 blank 13. This is another base Pythagorean triple that many of you will quickly memorize once you get the numbers in here. So in this case, though, we're looking for one of the legs. So our setup here is a little bit different because the y value is what we're plugging in for b, and we know the c to be 13. So we're going to have 25 plus y squared is equal to 169. If we subtract the 25 from each side, y squared is equal to 144, and therefore y is going to be equal to 12. So this is how we're going to apply the Pythagorean theorem in basic problems. We'll also get into some word problems as well.